Hello everyone, my name is Aditya. I'm a cloud solution technologist at Oracle. Today I'm going to showcase the capabilities of the OCI Network Command Center, a service that brings all the network diagnostic and troubleshooting services together for easier access and a unified user experience. It consists of four services: inter-region latency, which provides real-time and historical latency information between two regions; Network Visualizer offers network topology visualization to understand connections and relationships between your virtual network resources. Virtual Test Access Point or VTAP offers traffic mirroring capabilities that enable full packet capture for security analysis. And Network Path Analyzer, which allows you to troubleshoot complex virtual network configurations when you have reachability problems. We will learn and demonstrate the tools one by one. Now let's start with the inter-region latency. First, we'll go to networking, and under Network Command Center, click on Inter-region latency. The inter-region latency dashboard in the console provides the average network round-trip latency for all pairs of regions. First dashboard shows an average of values over the last 5 minutes. This information is presented in a grid format, allowing you to easily see the real-time round-trip latency between any region pair. This view updates every minute. The second dashboard shows a historical view of the last 30 days. You can select pair of regions from the drop-down to get the results. For example, I'm selecting Amsterdam and CDG and click on Show. You can also adjust time window as per your requirements. Use cases for this feature include network planning, disaster recovery, and troubleshooting performance issues. Now let's look at the network visualizer. Under the Network Command Center, click on Network Visualizer. This tool helps you view a high-level structure of your network configuration and facilitates quick navigation between its core components, with the ability to drill down into resources on the Network Visualizer map for more details. The opening diagram gives a high-level regional overview of the topology's various networking components. You can select the compartment from the drop-down and also choose to include the child compartments. The topology in this example shows how connectivity from the on-premises network is architected. Without looking at the DRG configuration in detail, you can easily see the routes for each DRG attachment. For example, in this topology, VPN1 connects to only OCI VCN and VPN2 connects to only OCI VCN1. You also have the option to download the network diagram in PDF or PNG format. Clicking on the resource gives you brief information about the construct. For example, DRG shows all the attachments, route tables, and route distributions. You can also highlight individual VCNs. The routing map gives detailed information about the subnets and other components associated with that VCN. For example, in this topology, we can see that OCI VCN has two subnets. Clicking on the individual subnet gives you the option to view route rules for that particular subnet. Security Map provides information about security lists or network security groups attached to each subnet. You can further drill down on the subnet inventory map to view what all resources are inside the subnets. Upon clicking on the resource, you can get additional information like IPs or shape. Security Map gives information on security list or network security groups association with the resource. As a network engineer, I can quickly get a network diagram with all this required information, and hence this tool is very useful in troubleshooting complex network scenarios. Now let's look at Virtual Test Access Point, also known as VTAP. I will be using this network architecture to show the demonstration. A web server is hosted behind a public load balancer serving HTTP traffic. A VTAP source can be an OCI database, Exadata VM cluster, instance VNIC, load balancer, or an autonomous data warehouse. In this demo, will use public load balancer as a VTAP source. The VTAP target must be a network load balancer in the same VCN as the VTAP source. Behind the network load balancer, you can host the network analytics tool of your choice. For this demo, I have used a simple compute instance as a backend and will be using TCP dump to analyze the traffic. Now let's get right into it. Before configuring VTAP, let's understand how network load balancer is configured. When the VTAP is configured, traffic captured at the VTAP source is encapsulated in VXLAN and then sent to the VTAP target, which is network load balancer, via UDP port 4789. Therefore, you must configure network load balancer to listen on UDP port 4789. Also, depending on your network design, make sure to allow UDP port number 4789 at all the applicable checkpoints such as security list or network security groups. Now let's navigate to VTAP. Click on Networking and under Network Command Center, click on VTAPs. Let's create a new one. Select appropriate VCN and source type as load balancer. In target, we'll select network load balancer. A capture filter is associated with a VTAP and defines what type of traffic to mirror at the VTAP source. Let's create a new one. Rules inside a capture filter are analyzed top to bottom to determine what traffic is mirrored. For this VTAP, I want to capture all HTTP traffic in both directions so that both traffic for the client request and web server response is mirrored. So I will create two include rules, one for each direction. On the traffic matching, the created rules is mirrored. So I will select TCP and destination port range as 80 to 80. For the second rule, I will select egress, again TCP, and same range for source port. When you create capture filter, it is automatically applied to the VTAP. Advanced options allow you to configure some parameters. You can specify different VXLAN network identifiers for each VTAP to differentiate between multiple VTAPs at the target. If a specific VNI is not selected, an unused one is automatically assigned to your VTAP. By default, packets are mirrored exactly as they arrive at the VTAP source. But VTAP also allows you to configure packet truncation for use cases where your network monitoring tool does not support full jumbo frames, or if you are only interested in analyzing each packet's header and the payload is irrelevant. If congestion occurs, mirrored traffic is dropped first. You can enable priority mode for VTAP and allow for mirrored traffic to be given the same priority as production traffic. This option is important for use cases such as compliance. Now I will go ahead and create VTAP. Whenever a new VTAP is created, the default status is stopped. Let us start the filter so that we can test. I have logged into the VTAP target compute instance. Let us start TCP dump for port 4789 and attempt to access web server through public load balancer. As you can see, we are able to capture traffic as configured. We can see VNI, source and destination IP, and HTTP data. Now let's talk about Network Path Analyzer. You can use Network Path Analyzer to analyze network paths within your OCI networks or your hybrid cloud or multi-cloud networks through Fast Connect or VPN. For the demonstration, I have used a simple setup of two VCNs connected to each other through a DRG. A virtual machine is deployed in each VCN, and we will be analyzing traffic between these two virtual machines. Let's get started. We will check if we can SSH from VCN1 instance to VCN2 instance. Under Network Command Center, click on Network Path Analyzer. Let's create new path analysis. We'll select protocol as SSH. For endpoints, you can select an IP address or an OCI resource. Since we have both of the virtual machines on OCI, we will select OCI resource from the top down. The OCI resource options include an IP address from a VCN subnet, a compute instance, a VNIC, and load balancer. We'll select compute instance and select VCN1 instance. If a resource has multiple IPs associated with the VNIC, you can select the appropriate address. Destination port should be 22. You can also choose to run analysis either unidirectional or bidirectional. Default is bidirectional. We'll run the analysis. In the analysis, you can see the diagrammatic representation of the network path with a number of hops. We can see that the status is unreachable and the issue is in the third hop of the connection. Details show hop by hop routing and security analysis. Now let's click on the segment to see a detailed analysis. We can see that the absence of an ingress rule in the security list is prohibiting the traffic. Let's click on the security list to verify. We can clearly see that the ingress rule allowing SSH traffic is missing. Let's go ahead and add that rule. Source CIDR should be the CIDR of the VCN1. We'll select SSH as protocol. Now let's rerun the analysis. Now we can see that the analysis is showing successful with all the hops. With large and complex networks, Network Path Analyzer avoids the manual process of analyzing hundreds of networking constructs such as route tables and security list. Additionally, since it doesn't need any traffic along the network paths, it is also an effective tool for troubleshooting as well as proactive configuration validation. To learn more about OCI Network Command Center, visit official documentation on docs.oracle.com. Thank you for watching the video.